Welcome back to Chem 101 with Moods. So, for this week's episode, lesson 3, we are going to be talking about, or we're going to be discussing a brief introduction to the periodic table. Now, if we go back to what we had started out with, just for recap, we already know that matter is anything that has mass and takes up space. We already know that matter consists of atoms. Atoms are the smallest units of matter, so it's the smallest unit into which matter can be divided. And atoms can be broken down into subatomic particles. So there exists protons, neutrons, and electrons. Now, this slide compares the charge, mass, and location of our protons or neutrons and our electrons. So the protons and the neutrons have the same mass. The mass is about 1 gram. The electron, in some books you're going to see their gram to be 0, but in some books you may see 1/1640 or 1/2000. If we should divide that through, we're going to be getting 0.000006. So the mass of the electron is negligible compared to the mass of the neutron or the mass of the proton. And what that basically means is that the mass of the electron, you'd need about 2,000 electrons in order for it to weigh as much as a proton or a neutron. We also need to be aware of the location for the protons, neutrons, and the electrons. So the protons and the neutrons are located inside the nucleus, and that's why the nucleus is positively charged, because the protons have a positive charge. The nucleus are electrically neutral, so there's no charge. The electrons are located in orbit, so they're going around. Based on the level of chemistry, you may talk about energy shells or you may talk about orbitals, one in the same. But the point is the electrons are in orbit, so they're going around the nucleus, and they're able to stay in their place because they are electrically negative, so they have a negative charge. The nucleus being positively charged because of the presence of the protons, so the protons are keeping the electrons attracted to the nucleus. These diagrams, they show different models of the atom. So there's one on the right, there's one on the left, and the whole point of this, or the basic idea, is that the protons and the neutrons are in the center and the electrons are in orbit, so they're going around the nucleus, and the nucleus being positively charged because of the presence of the protons. Now, this is what the modern day periodic table looks like, and it is organized based on an increasing atomic number for each of the elements. So if you should pick any random element, let's look at, beryllium. So the atomic number for beryllium is 4. If you pick an element that is below beryllium, it's going to have an atomic number that is less than beryllium's atomic number. And if you pick one that is higher up on the periodic table, then it's going to have an atomic number that is higher. Now, where do we find these numbers? Because on the periodic table, you may see different numbers. What do they mean? So for example, if you should look at carbon, carbon has an atomic number of 6. That's a smaller number in the box. And the weight for carbon, or the mass of carbon, is 12. So the bigger number is the atomic mass, or the atomic weight. The smaller number is the atomic number. Now, the atomic number, you can also use it to figure out the position of the element on the periodic table. So because carbon has an atomic number of 6, it means that it is element number 6. It is the 6th element on the periodic table. If you should look at another example, for example, magnesium, because magnesium is the 12th element on the periodic table, then magnesium is going to have an atomic number of 12. Now, the atomic number is going to be equal to the proton number, which is going to be equal to the electron number. The mass number is the proton number plus the neutron number. The mass number, if you subtract the atomic number from the mass number, then you're going to end up with the neutron number. What does all of that mean? So looking at sodium on the periodic table, the smaller number in the box is 11. The bigger number is 22.990. So let's round up to 23 for calculation purposes. So the mass number, we said before that it's the bigger number in the box. So the mass number is 23. Because the mass number is 23, then the atomic number, the smaller number in the box, is going to be 11. Now, the atomic number is also equal to the proton number, which is also equal to the electron number. So the atomic number being 11, it means the proton number is 11, and it also means the electron number is 11. Now, the mass number is going to be the proton plus the neutron. So if we're looking at sodium based on the screen, we have the mass number, which is 23, and we have the atomic number, which is 11. So 23 subtract 11 is going to give us 12, which is my neutron number for sodium.